Hello students, today we are going to read about measurement and instruments. What are the types of instruments? In this class we are going to discuss about moving iron instruments. It is one of the most accurate instrument used for both AC and DC measurement in moving iron instrument type. The most common ammeter and voltmeter for laboratory use or switchboard use at power frequency are the moving iron instruments. The instruments can be constructed to measure current, voltage to an accuracy needed in most engineering works and still be cheaper as compared any other type of AC instruments of same accuracy. Moving instruments are classified in two types. The first one is attraction type and the second one is repulsion type. So we have to discuss first attraction type MI instruments. Attraction type moving iron instruments. The construction of an attraction type moving iron instrument, the coil is flat and has a narrow slots like opening. A moving iron instruments consist of a flat cylindrical coil. The moving iron is a flat disc or oval shaped disc pivoted on a simple spindle. A pointer is attached to the spindle which moves on a calibrated scale. The controlling force is obtained by gravity control system. The damping force is provided by air friction with the help of light aluminum piston attached to the moving system. In this figure, here is the piston and here is the coil and this is the scale. This is a balance weight attached to the spindle. This is the moving iron part. Then counter controlled weight is controlled. This is the constructional diagram of a attraction type instrument, MI instrument. Let us discuss about its working principle. The moving iron disc or a sector essentially mounted. When the current flows through the coil, a magnetic field is produced and the moving iron moves from the weaker field outside the coil to the stronger field inside it, or in other words, the moving iron is attached to the controlling torque is provided by the spring. But gravity control can be used for a panel type of instrument which are vertically mounted. The damping is provided by air friction with the help of light aluminum piston. In simple language, we can describe its operation when the current to be measured is passed through the fixed coil. As the current is low through the fixed coil, a magnetic field is produced. By the magnetic induction, the moving iron gets magnetized and then the north pole of the moving coil is attached or is attracted by the south pole of the fixed coil. Thus, The deflecting force is produced due to the force of attraction. Since the moving iron is attached with the spindle rotates and the pointer moves over the calibrated scale. But force of attraction depends upon the current flowing through the coil. This is all about the working principle of attraction type moving iron instrument. Then coming to the second type of moving iron instrument, that is repulsion type moving iron instrument. In the repulsion type, there are two bands inside the coil. One fixed, other is movable. Radial band type and a coaxial band type. For the radial band type, the bands are radial strips of iron. These strips are placed within the coil and the fixed bands is attached to the coil and the movable one is to the spindle of the instrument. In repulsion type instrument has a hollow fixed iron attached to it. The moving iron is connected to a spindle. The pointer is also attached to the spindle in the supported with a jeweled bearing. In repulsion type instrument, the pointer is attached to the spindle with the support of a jeweled bearing. In the next figure, we will show the construction of a repulsion type moving iron instrument. Then coming to the working principle. When the current flows through the coil, a magnetic field is produced by it. When the current flows through the coil, a magnetic field is produced by it. So, both fixed iron and moving iron are magnetized with the same polarity. Since they are kept in the same magnetic field, similar poles of fixed and moving iron get repelled. Thus, the deflecting torque is produced due to magnetic force of repulsion. Since moving iron is attached to the spindle will move so that pointer moves over the calibrated scale. The damping is we can say air friction damping is used to reduce the oscillation, and the spring control method is used to control the movement of the pointer. Then the controlling torque is provided by the spring. The damping torque is provided by the air friction damping. The operating magnetic field in moving iron instrument is very weak, and therefore eddy current damping is not used in them, as introduction of a permanent magnet required for eddy current damping would distort the operating of magnetic field. This is all about the working principle of the moving iron repulsion type instrument. Then coming to the advantages and disadvantages of moving iron instrument. First, we will discuss the advantages of moving iron instrument. It can be used for both DC and AC currents. The moving iron instruments can be used for both DC and AC currents, or we can say the instruments are suitable for use in AC and DC circuits. Then simple and robust in construction. It is very simple in construction. That is the one of the advantages of moving iron type instrument. Then the third point is cost is low due to its simple construction. Then Frictional errors are negligible due to high torque to weight ratio, as the moving parts are of the lightweight is all heavy part of the instruments are stationary parts. Then we can say the stationary parts of the instrument are also simple. No contacts leading systems are required for the moving system, as it does not carry any active current through it, and high operating torque is produced in it, or you can say torque or weight ratio is high, thus less frictional error occurs in the instrument. The instrument is low cost compared to the other instrument. It can withstand to overcurrent for short periods, which is quite common in AC circuits. The instrument is accurate for designed frequency range, which makes it useful for precision and industrial requirements. Then going to the session disadvantages of EMI type instruments. The first disadvantage is the scale is not uniform. Then for low voltage range, the power consumption is very high in this type of instrument. The errors are caused due to hysteresis in the iron of the operating system and due to stray magnetic field. In case of AC measurements, change in frequency causes serious errors. With the increase in temperature, the stiffness of the spring decreases. Then coming to the error parts of this type of instrument. In this type of instruments, errors arises due to variation in temperature, due to friction is quite small, as torque weight ratio is high in moving coil instruments. Stray fields cause relatively low values of magnetizing force produced by the coils. Efficient magnetic screening is essential to reduce these effects. Error due to variation of frequency causes change of reactance of the coil and also changes the eddy current induced in the neighboring metal. The deflecting torque is not exactly proportional to the square of the current due to nonlinear characteristics of iron materials. This is all about the moving iron type instrument.